Hello and welcome. This is going to be lecture number 6. Go ahead, get out your notes, and you might want to have the blank copy of the periodic table that I gave you in class out as well. But you're fine to just do this in your notes if you don't have that periodic table. Put today's date at the top, and let's get started. All right, so go ahead and sketch for yourself a quick periodic table. You don't have to get every single element on there. But what I want to point out in this periodic table is that it's organized into rows and columns that we call groups and periods. And so across the top, we number each column with a group number 1 through 18. And then each row gets a period number 1 through 7. One way to remember this is that you guys typically have 7 periods in a day. And here our periodic table has 7 periods. So that's kind of a good way to remember that this side should be the periods number because you wouldn't have 18 periods in one school day. Something that's really nice about the way that this is laid out is that elements in similar groups have similar properties to one another. And that's why it is this kind of a half-pipe design is so that we could better line up elements that have similar properties, and we're going to talk about those different groups now, but don't mix up your groups and your periods. Now, with the periodic table that's on the wall in the classroom and some of our handouts, you might see an additional way of numbering the groups. This first column is called 1A, and then this next column is called 2A, but then it resets, and this column here is 3B, and then 4B, and on, and then we have a group that's multiple blocks wide called 8B, and then in group 13 it's called 3A again, and then counts up from there. We won't use that group numbering, but just know that that group numbering is supposed to help you more quickly tell how many valence electrons an element might have. But we'll just always go 1 through 18 when I'm talking about the groups. There are many ways to break down the periodic table and the different trends that we see within it, but one common way to break it up is into metals, which are on this side, and nonmetals, which are on this side. They're separated by what we call the periodic staircase, and elements close to the periodic staircase are called metalloids, which have properties of both metals and nonmetals. So you could just sketch a real quick periodic table and then draw on this diagonal line, which is the periodic staircase. And the periodic table in class has this in bold to make it easy to separate the metals from nonmetals. Now, a few that can trip you up is hydrogen up here. Hydrogen is a nonmetal. And then with the metalloids, you do not have to know specifically which ones are metalloids. Just know that elements near that periodic staircase might have properties of both metals and nonmetals. For example, polonium and astenine down here are sometimes called metalloids, sometimes not. Interesting story about astenine is that it's so radioactive that it just becomes a vapor the second it's synthesized, and it's really hard to study what its properties would be. So they're kind of question marks. And so I would never test you on specifically what is a metalloid, but I would test you on a nonmetal versus a metal. You need to know that, for example, iron right here is a metal. It's well within the metal side. Or helium over here is a nonmetal. It's well within the nonmetal side. And I would like you to also know a few properties of metals and nonmetals. I'm going to write them down here, and you should do the same in your notes. So metals, they are ductile, which means that they are not brittle. They can be bent without breaking. And they are lustrous, which means they're shiny. And most of them are good conductors of heat and electricity. Nonmetals, on the other hand, they're not ductile, they are brittle. They're not lustrous, they are dull. And they're poor conductors. And a lot of that is the fact that they exist as gases at room temperature, so poor conductors. Now, another way to break up the periodic table is to break it up into the representative elements, the transition metals, and the intertransition metals. Know that representative elements could also be called the main group. Those are synonymous. Now, to take notes on this, you don't have to draw this. What you could do is just write the group numbers. Representative elements are groups 1, 2, and 13 through 18. Transition metals are groups 3 through 12. And then with intertransition metals, maybe just write that that's the block below the periodic table. We'll start abbreviating that PT. All right, and here we see a few other very important groups on the periodic table labeled. Let's start with group 1. Group 1 are called the alkali metals. Group 2 are the alkaline earth metals. And then group 17 are the halogens. These three groups, one thing I'd like you to know is that they're very reactive. And groups 1 and 2 like to react with group 17. Alkali metals like to form salts with halogen. Now there's the noble gases on the far side here. This is group 18. Noble gases, although they are right next to the very reactive halogens, they are not reactive at all. And it's actually halogens want to basically become noble gases, and that's why they are so reactive. Because noble gases are so stable, halogens, they're sort of like trying to become a noble gas by reacting and picking up an electron. Now, noble gases, they are not reactive. They're incredibly stable. They're not going to form bonds with other elements. Now, at the bottom, we have our intertransition metals are broken into two series, the lanthanide series and the actinide series, named after these two elements here, which often go at the front of this group. You could think of these series extending out of the periodic table into the z-axis. This is where they would go to follow a lot of our trends, but if we put them in there, it'd either make it too wide or they'd have to come out in 3 dimensions. There's not too much that I would quiz you on here, but I think it's kind of fun to know that the lanthanides, these are considered our rare earth elements. So rare earth elements. And then the actinides, these are all radioactive. 100% of these are radioactive. We see some popular ones like uranium and plutonium in here, but they're all radioactive. There's other radioactive elements in the main body of the periodic table, but all actinides are radioactive. All right, we'll call that good for this lecture video. I'll embed a few more questions here for you, and have a good rest of your day.